Welcome back all of you. This class I am going to discuss about De Morgan's theorem. Before going to the De Morgan's theorem, first we can see how to draw a logic gate circuit for a given Boolean expression. Draw a logic gate circuit using fundamental gates for a given Boolean expression. In the given question, A plus B complement C. F equal to A plus B complement C. That is a given Boolean expression. Here to draw a logic gate circuit for A plus B complement C. So this is the logic gate circuit. See then last class we studied about different types of logical operation. Not operation, and operation, or operation. Not has high precedence, then the and operation, then or operation. So here also, your expression is A plus B complement C. So not has the high precedence. So B complement should done first. After that and. So that means B complement into C, the next operation. After that A plus B complement into C. So this is the way, this is the order of the execution. See, the first thing you have to do A B complement, or you have to generate B complement. Complement means that is the negation operation. Negation operation is done by using NOT gate. See then I just draw a NOT gate here and B is the input for the NOT gate and the output of this NOT gate is B complement. So this is the B complement operation. Next you have to generate B complement C. So that is B complement C means that is the AND operation. AND operation is done by using AND gate. So AND gate, this is the AND gate. We studied that AND gate will take two or more input and produce one output. So this is the AND gate. One of the input of this AND gate is this B complement. Output of the NOT gate will be given to the AND gate. So B complement is the input of AND gate. And the next input is C. So this is C. C is drawn like this. And that C is the input of this AND gate. Now the output will be B complement C. B complement C will be the output. And the next operation is OR operation. That is done by using OR gate. So this is the OR gate. The output of the input of the OR gate. One of the input of this OR gate is B complement C. So you got that B complement C here. That is given as the input for this OR gate. And the second input of this expression is A. That is given to this OR gate. See that this is A and that is one of the input. And B complement C, that is the second input for this OR gate. That will produce A plus B complement C. This is the way you have to draw a logic circuit for the given Boolean expression. First you have to identify the order in which the execution is taking place. The first NOT operation and next AND operation, then OR operation. So that is the way you identify the operations, then take the corresponding gate and draw the circuit. So you have to label each of the input and each of the output. For each gate, the input you have to label and the output also you have to label. Here for this OR gate, B complement C is the input. That is why I written B complement C over here. And the second input is A. That is why I written for this line the input as A. So that is given to this OR gate. And it's produced this output. So output also labeled like this. So when you draw the logic circuit, you have to label both input and output. Now I'll show you certain question. This question you have to do it in your notebook. Write down when you write the notes, write this question and draw each case, draw the logic circuit. Here the first question I'll discuss y equal to u v complement plus u complement w complement. So here v complement is there. So that means you have to use a NOT gate and generate v complement. V is the input and output will be v complement. And use an AND gate to generate u v complement. So that part is over. And take the next part. Next part is here also complement is there. So complement should done first. So generate u complement and w complement. and connect these two together in an AND gate. And both these output you have to connect to an OR gate. So that is the way you have to generate, or you have to draw the logic circuit diagram. And next we can see De Morgan's theorem. So this is De Morgan's theorem means there are two theorems for De Morgan. First theorem is A plus B complement, A plus B the whole complement equal to A complement into B complement. The variable can be anything. It is not same as A and B. You can use any variable over there. I can say the De Morgan's theorem as x plus y the whole complement equal to x complement into y complement. That is the first De Morgan theorem. And the second De Morgan's theorem is written as A, B the whole complement equal to A complement plus B complement. Or I can say x, y the whole complement equal to x complement plus y complement. So that is why I told you the variable can be anything. It's not compulsory that you have to use A and B itself, but the expression must be same. A plus B the whole complement equal to A complement into B complement. That is the first De Morgan's theorem. And the second De Morgan's theorem is A, B the whole complement equal to A complement plus B complement. Now we can prove this De Morgan's theorem by using truth table. So it is written, this is second De Morgan's theorem are written over there here. This is A plus B complement. So it is not and, this is A plus B the whole complement equal to A complement into B complement. That is the first De Morgan's theorem. This is a typing mistake. See that this is A plus B the whole complement equal to A complement into B complement. Don't make the mistake in your notebook. Correct this as A plus B the whole complement. You have to draw. You have to prove this one by using truth table. I am going to prove it. I will change the screen and I will take the other screen where we can prove it. See that? Yes. Here I am going to prove this. I will change it first here. This will be A plus B the whole complement equal to A complement into B complement. See that how many variables are here in this expression, or in this Boolean expression. How many variables are there? Only two variables. So that is why I just written two variable. We studied in the previous class two variable truth table consists of four combination of values. Two variable truth table consists of four combination of values. I am going to write the combination values. The first value 0, 0. Can you say what is the second value? 0, 1. And what will be the third value? 1, 0. And what will be the last value? It will be 1, 1. So A and B, these are the variable values. It's a combination, input combination I just written over there. And next thing, we have to prove it. Left side, we have to prove the left side LHS is equal to RHS. So I am going to take LHS first. First you have to calculate A plus B. So I will write it over here. This is A plus B. A plus B. See, this is A plus B. That means your OR operation, not binary addition. This is OR operation. So this plus represent OR operation. A plus B. 0 plus 0, 0. 0 plus 1. 1, 1 plus 0, 1, 1 plus 1, again 1. We studied that in OR operation, if any one of the input is 1, then the output is 1. So you got the output as this one. And the next part in the left, LHS. LHS, the next part is A plus B the whole complement. Complement, you can write it this way, or the other symbol also you can use it. Now, here. A plus B, already you calculated A plus B. This is the A plus B column. Its complement, its negated value. Whatever the input, its opposite will be the output. So its negated value will be, it is 0 is the input, so output will be 1. 1 is the input, 0 will be the output. Again 0, now it is 0. I think it's clear for you. Now the left side, LHS is proved, LHS is completed there. Now I am going to do the RHS part. So that is, first you have to calculate A complement. So this is A complement. Your A is this one. Its complement value is A complement. So this is the A value, A input value. Its complement we are going to calculate. First A value is 0. Its complement is 1. Second A value again 0. Its complement 1. Next is 1. Its complement is 0. Again 1. Its complement is 0. Next calculate. So complement, that means NOT operation should do first. So that is why I am doing B complement here. Now which is the B value? B value is here. Now find out the complement of each of this B value. 1, 0, 1, 0. So this is the B complement value. This is the B value and this is B complement value. Next, I am going to complete that RHS. A complement into B complement. A complement, this is A complement and this is B complement. A complement into means AND operation. A complement and B complement. So that is these two values you have to perform AND operation. AND operation will produce one output if both the inputs are 1. If both the inputs are 1, then AND operation will produce one output, right? Yes. So here it is 1 and the next input 1 and 0. So the output will be 1. Here also output is 0 and here also output is 0 and here also the output will be 0. Now you check it whether the RHS is equal to LHS or LHS is equal to RHS. Which is the LHS column? LHS column is this one. This is your LHS and here this is your RHS. So from the above, you have to write it here. From the above table, we can say A plus B the whole complement equal to A complement into B complement. So that is a final solution. You have to write it over there. From the above given table, we can say A plus B the whole complement equal to A complement into B complement. So that is your De Morgan's first theorem. Now we can see De Morgan's second theorem. So De Morgan's second theorem is this one. Before going to give De Morgan's second theorem, we have to draw the logic circuit diagram for De Morgan's first theorem. Logic circuit diagram for De Morgan's first theorem. So A plus B the whole complement. Bracket will get the high precedence. So the first you have to generate A plus B. And next you have to generate its complement. So A plus B can be done by using OR gate. And its output you have to connect to a NOT gate to produce its negated value, which is equal to again A complement into B complement. A complement you have to connect to a NOT gate, you will get A you have to connect to a NOT gate, you will get A complement. B you have to connect to a NOT gate, you will get B complement. These two output you have to connect to AND gate, you will get the final output. I will show you the circuit diagram for your De Morgan's first theorem. See that A plus B the whole complement equal to A complement into B complement. Left side, this is the left side part. A plus B, plus is OR gate. See, this is OR gate. A and B are the input. Output will be A plus B. And you have to calculate the complement. So this output I am connecting to a NOT gate. NOT gate has only one input, so only one line is connecting to NOT gate. That will produce A plus B the whole complement, which is equal to, and you have to calculate the you have to generate the right side output. Right side, the first one A complement. A complement means you have to use a NOT gate. So here the NOT gate is here and whose input is A and the output will be A complement. Second NOT gate, this one, whose input is B and the output will be B complement. So both the NOT operation you perform and next you have to perform AND operation. For AND operation, you have to use AND gate. See that AND gate I use. Both the input, both this A complement and B complement value connected to or given to AND gate. So this is the AND gate. So two input is given. One input is A complement and second input is B complement, which is given to AND gate, and that will produce A complement into B complement, or you can say A complement and B complement. So this is the way you can draw the circuit diagram for De Morgan's first theorem. Look at the theorem and identify the first operation, and based on that select that logic gate and draw this diagram. Now next we can see the proof of De Morgan's second theorem. De Morgan's second theorem. So here this is De Morgan's second theorem. A into B the whole complement equal to A complement plus B complement. Here also only two variables, A and B. I'll write the input value. So two variable means four combination of values 0, 1, and here it is 1, 0, and the last combination value 1, 1. Now see the left side. Left side is bracket you have to do first. So first I am going to calculate AB. AB means AND operation. AND operation means both the input must be true or both the input must be 1, then only the output will be 1. So here it is 0, this is 0, here it is 0, here it is 1. And now the next left side, next operation is A into B the whole complement, A into B the whole complement, AB the whole complement. So you calculated AB, its complement is 1, 1, 1 and 0. This is AB the whole complement. Next I am going to take the right side, the left side calculation or again left side table preparation is over. Now I am going to prepare the right side table. So that is A complement. A complement, A is here, this is the A value, its complemented value will be 1, 1, 0, 0. And the next one, B complement, I'll write it B complement here, this is the B value. How will you find out the B complemented value? 1, 0, 1 and 0. So now the next operation, A complement plus B complement. That means OR operation. A complement is this one and B complement is this one. So OR operation. Any one of the input is 1, then the output is 1 in OR operation. So here 1, this is 1. And here 1 and this also 1. Check it, both left and right is equal. Left side is A plus B the whole complement 1, 1, 0. Right side is A complement plus B complement. So again 1, 1, 1, 0. So both are equal. So you can say from the above table we can say then A, B the whole complement equal to A complement plus B complement. That is your De Morgan's second theorem. The next step, we have to draw a logic circuit for De Morgan's second theorem. Can you say which is the first gate that you will use it there in the LHS? LHS, which gate you have to use first? Yes, it is AND gate. How many input? 2 input. What are they? A and B. So A and B are the 2 input given to AND gate. Will give you A, B as the output. That output you have to give you a NOT gate which will give you A, B the whole complement which is equal to. Next you have to generate A complement and B complement. So you have to use 2 different NOT gate. One NOT gate the input is A and the output is A complement. Second NOT gate input is B and the output is B complement. These 2 output of the NOT gate you have to give to an OR gate will give you the answer A complement plus B complement. One more time, take the left side which is the first gate, AND gate. See that picture? First gate is AND gate. A and B are the input. Output will be AB. And which is given to a NOT gate. You will get A, B the whole complement which is equal to right side A and B 2 NOT gate you will produce A complement and B complement. NOT gate will take only one input, so that is why it just given one line over there that represent only one input is there. So 2 outputs, one for this one and one for this one. Both are connected to OR gate. You will get this is A plus this is A plus B the whole complement, A complement plus B the whole complement. So that is your second De Morgan's theorem. A, B the whole complement equal to A complement plus B complement. So this is A complement plus B complement. So this is the way you can draw the logic circuit diagram for second De Morgan's theorem. So the first De Morgan's theorem is A plus B the whole complement equal to A complement into B complement. Second De Morgan's theorem is A into B the whole complement equal to A complement plus B complement. So this is all about De Morgan's theorem. Now I just prepared few homework questions there. After completing the notes, at the end you write out this question and each one you have to do it in your notebook. Each write the question. After each question you write the answers also. So complete that homework question. One more page is there. This is the second page. See this question. Write the equivalent Boolean expression for the following logic circuit. So whatever the output, or you have to generate a Boolean expression for this logic circuit. One I'll explain here. This is U. See then here this is V. V is given to this NOT gate and here it will produce V complement. And this AND gate will produce, what is the output of this AND gate? U V complement. This will give you U V complement. You don't want to write on this picture. You write the final output as Y equal to, and Y equal to, this is U V complement, and that is this output. And here, see that here this U is given to this gate. That means here you will get U complement. This is not gate. The input is U. So U complement will be the output. W is the input here. W complement will be the output. So that is given to this AND gate. So what will be the output here? U complement, W complement. So that is the output here coming over here. And which these two output we are giving to an OR gate. So you can write the final answer as, I'll write it. You can write the final answer as this way. Y equal to, see that U, this is U and this is V. So the output will be U V complement. That is the output coming over here is the AND gate. And the next output is here. I am not writing any symbol over there. The next output is U complement. U complement, W complement. That is the output you are getting over here in the AND gate. And these two are given to OR gate. So this output and this output both are giving to an OR gate. OR gate will perform plus operation. So your output will be the Boolean expression of the given logic gate is this one. This is the U V complement plus U complement W complement. Same way you have to find out the output of this one. One more I will explain. Here U complement and here it is V. This is OR gate. So the output will be U complement plus V and here it is V complement plus W. Both are given to AND gate. So the final answer will be U complement V, U complement plus V into V complement plus W. So that is the way you can write the answer here for the second question. So complete these two as the homework question, complete it in your notebook. That is all about logic circuit and De Morgan's theorem. So now that chapter is over. There is one more small topic is there that I will take it last. Now here the chapter is over. Now the next class I will start the next chapter. Here children, I just written 16. That 16 means it is the base. This 10 means it's the base. That means you have to convert this hexadecimal value to decimal. Same way here also convert this 10. This 10 represents it is a decimal number. The decimal you have to convert into octal. Next question, convert 321 8. This 8 represent it is an octal number. This octal number you have to convert into hexadecimal. Same way the remaining here also the same thing. 105.15 base 10. This is 10 base 10. You have to convert into binary. that is binary question. So that is all about that chapter. Next chapter we can study in next class. Next chapter is the beginning of the Python language that we can study in the next class. Okay. Thank you, children.